Hey, this is Sanyam Bhutani, and you're listening to Chai Time Data Science, a podcast for data science enthusiasts where I interview practitioners, researchers, and Kagglers about their journey, experience, and talk all things about data science. Welcome to Chai and Hardware, ctds.show. In this episode, I got to chat with Charlie Boyle from NVIDIA. Charlie is the VP and GM of DGX Systems at NVIDIA. NVIDIA recently announced and released their DGX A100 systems, a refresh of the same. So these have been around for a bit. And the reason I'm talking about that, these are ridiculous systems. I really don't see myself using them, but to me, and the part of this conversation that we had was the interesting engineering that goes on inside of these. These systems have 320 or 640 GB of GPU space, a very powerful CPU in there, and yet these use less than 1500 watts, about 1500 watts of energy. Also, if you want, you can enable Meg, which creates you to create 28 individual GPU-like instances without any overhead. And all of these interesting engineering aspects was something I really wanted to dive into. That's what we discuss in this conversation. We don't discuss a lot of benchmarks because this is really the cutting edge and these are the fastest GPUs. If you're interested in checking those out, you can find the blog by NVIDIA in the show notes. But if you're interested in knowing about the engineering that goes on behind the scenes for creating the cutting edge, for pushing the envelope of graphic cards, and hopefully how that'll bleed into a 4090 or 5090, I won't stand between you and the conversation. Please enjoy the show. I'm very excited to be talking to Charlie Boyle from NVIDIA. Charlie, thank you so much for joining me on the podcast.
Thanks, Ty. I'm glad to be here. It's been a great week at supercomputing.
You've had a lot of exciting stuff announced that I can't wait to dive into. But first, before that, I'd love to know how you got interested in the world of machine learning and your role at NVIDIA.
Sure. My background, I've always been involved with large systems, data center companies. I've worked for service providers. I've worked for manufacturers. And an opportunity came up about 5 years ago when I had some friends that were working at NVIDIA, and they said, hey, we're going to build this brand new AI server, this AI appliance, and we think you'd be a good fit to help us on that journey, with the background that I had in data center and servers. And, I joined the team about 5 years ago, just about a month before we launched the first DGX one. And as a company, that was our first real enterprise product that we sold as a server. We'd sold a dev box before that, but in terms of a wide scale global product, the DGX one was that first purpose built system that we built to kind of be the absolute best that you could build on the GPUs that we had at the time. At the time, it was Pascal P100, so we wanted to show the world how good that system could be, how our new innovations could really come out to market. And I was sold on that. I didn't have a lot of background in machine learning at the time. I did a lot of data analytics at other companies as a user of big data. But it was I was able to bring some knowledge of big systems, and I learned a ton from the practitioners that we had here, what their pain points were, and it's been a great ride ever since.
So could you help break down the architecture names, because that's one thing I always get confused with.
Yes. Yeah, and it's something that goes from our history, as building the best GPUs that you could put into a system. Now, how do you name that as an actual system itself? So, when we started the DGX product, we knew we were going to call it DGX, and we had a lot of interesting questions early on. Does DGX actually stand for? Is it an acronym? And it's not really an acronym. It's just the product name. There's been lots of speculation of what it is, and so it was our first system. So we said, well, that's DGX One. Kind of makes sense. But the DGX One was based on our Pascal architecture, our P100, and the 100 series chips are always our high-end data center chips. So that's kind of the short secret decoder. If you see an NVIDIA product that says P100, V100, A100, those are all always our top end, largest data center parts. So in our DGX One generation, and this is also where it gets a little confusing, in that same server chassis, we went from Pascal to Volta, and we didn't change the product name because when you looked at the outside of it, it still looked the same. But we also very quickly stopped selling the Pascal version of it because once Volta was out, everyone, bought the Volta. There was no real reason to keep it around. And then when we went to DGX2, the reason we did a name change there was because that was a much larger system. That was a 16 GPU system. It was still Volta, but we had a lot of technical advances in the system. It was the first time we had NV switch. The first time we tried to do 16 GPUs. So when we make a major change, that's when we tend to change the product name. But again, that was still Volta based. So you had a DGX One that was 3 rack units, and that was Volta based. You had a DGX 2 that was 10 rack units. And so partially based on, that kind of market confusion that there wasn't a tight tie of GPU architecture to the DGX products, as we went into the Ampere generation, we had lots of discussions about what we should call it. Naturally, you could say, well, it'd be DGX 3. But at the same time, we wanted to start a new naming standard that kind of coupled the product to the GPU generation that it was in, because our goal is to not have to have a new chassis every time we have a GPU generation. So, like any great design center, you want to do the best, but at the same time you want reuse. So we've moved to now DGX, and then the process or the GPU architecture family, A100 being the current one. And you'll notice in just what we put out in the press releases that we're also further differentiating those products with the total GPU memory size. So, you have things like the DGX A100 320 gig or the DGX A100 640. And similarly on our DGX Station is the base name of the product. And then now we have a DGX Station A100, and similarly, you have a 160 gig and 320 gig version of that. When you see us talking about it in general, we'll tend to drop the capacity number unless we're talking about a specific capacity system.
That makes sense. But the person in me who just got a 3090 is trying to think, who are these ridiculous people who need that amount of memory? So was there an origin point where you really felt that maybe it's trying to push the envelope? Because one thing I learned was the DGX boxes really push the envelope. So how did that originate? Do you know the inception point of that?
Yeah, and when we started the design and architecture for DGX and NVIDIA, that was really Jensen's design goal, the soul of the product, and that it continues to be the soul of the product, which is taking our absolute best GPU technology and finding a way to put that in a package for customers that makes full use of the GPU. So our design center is always, what is the fastest GPU that we're going to possibly build in a generation? Then how do you design a system around that so customers can easily run those GPUs at 100% capacity? So that's why you see some of our systems, and they're slightly larger on the server side than some other designs, because we build in a lot of thermal headroom, a lot of power headroom. We have fully redundant power. So even in the DGX2 generation, we were able to turn up the power mid-generation and didn't need any changes in the system because we had enough overhead. So from a design philosophy, it's always build a system that has as much new technology to future-proof our customers we try to build things in a modular way so they're upgradable, and then do it in a way that leverages the absolute best technology at the time, knowing customers are going to have to use these things for a number of years and they don't want their system to be obsolete. So that's our design philosophy. And we start with that, and then we build all the components around it. Our latest A100 GPUs, move from Gen 3 to Gen 4 PCIe. So we said, okay, now we need to build a system that's 100% Gen 4 internally, even though Gen 4 is not that widely out in all of the elements in the market. So that was a big design challenge for us. And luckily we've got really talented engineers to go do that work and push the limits.
So just to let the audience know, the GPUs connect using PCI lanes, and Gen 4 is the latest standard. Gen 3 was the last one. Usually there's, if I remember correctly, twice as much speed up with every generation.
Yeah, so in Gen 4 was a big thing for us because the Ampere generation was so much more powerful on the GPU side. And of course, inside of the system, we have NVLink that connects the GPUs to each other, but you still obviously have to connect to IO and CPU, for the total system. So, that's why we changed to an all Gen 4 IO design internally. That's also when we first launched the system, why we had moved to the AMD generation of CPUs, because they were at the time the best, and I think still really the only Gen 4 capable CPU out there. And we got a lot of press attention and inquiries about, oh, you guys are using AMD CPUs. But that fits our design philosophy perfectly, which is we're always going to use the best parts. If the best part is Intel, we use Intel. The best parts AMD. If the best memory controllers, this other company, we always use the best, and we don't apologize for that. And it's not a competition thing. It's not like we wouldn't use somebody's CPU because it was the best because they happen to be a competitor. It's we want to deliver the best.
That makes sense. Do you have any thoughts? Because I know the 3000 series also stirred up a lot of interesting conversation in the hacker community. People were sleeping outside of micro centers just to get their hands on one. Where do you think people draw the line? Because or just individual enthusiasts like me would like to hack a rig together. Is there a line where we should prefer renting a server, or just maybe a A100 if those go up on AWS or such vendors eventually?
Yeah, it's really about what you're trying to do with the system. Part of our overall architecture across NVIDIA is it's one NVIDIA platform, one software stack. So you can run CUDA on the 3090 that you have. That exact same CUDA program runs on the fastest DGX today. So it's really about your use case and what you're trying to do. We have lots of data science enthusiasts that start with our consumer cards, especially as you're talking about people that are early in research. Maybe they're in university, or maybe it's something that they're doing as part of their job, but it's not their full-time job. And they're but I used to be an amateur data scientist as I was working through a ton of data at my last company. I would never say to my manager, hey, can I go buy, a really big machine? Because I was doing it, for analysis a few times a month. If it's a core part of your job, that in my mind, as I advise customers, that's really the break point for me. Is if it's something that you need to get done for your job, then that should be something that you should be using our enterprise data center grade systems, whether you buy a DGX, whether you buy an OEM system, with our A100s, or whether you go to a cloud. Those systems are designed for the the highest performance, to get you the results the fastest that you need. I can remember an example, maybe a year and a half ago, where we were working with a startup company who their data scientists were all using, at the time it was 20 series. And the CEO of the company had just bought them a DGX1, and the employees were so happy because the work that they were doing on their 20 series, while it was great, their data scientists had to wait 3 weeks for a result.
Wow.
And it was an emotional thing for them, because when they had a good result, they were happy, but when they had a result that wasn't what they wanted, they feel like they wasted 3 weeks of time. And when they got their DGX1, they were getting results in half a day. So their data scientists, their researchers were able to, start an experiment in the morning, go to lunch, get results, start another experiment. So they felt freer to do more things. And so, like I said, it kind of goes back to, if it's a core part of your job, then use the data center grade stuff, because that's really what's going to make sure that it's running 24/7 for you. But that's part of our advantage, that from your laptop all the way to the biggest system, it's the same software.
I'd be mad if 3 weeks of sword fighting was taken away from me, but
but that's that's where AI is these days. It's, the models are exploding, everything's getting bigger, and sure, you can start on some consumer parts for your experimentation, but like you said, if you're 3 weeks in, 2.5 weeks into a 3-week run, and your PC crashes, hopefully you did a checkpoint on it. But it's one of those things that if it's worth it for your job, then it's worth the value to move up to the higher end parts.
absolutely. And like you mentioned, the workstation grade GPUs have extra performance enabled on them. So do you know, or can you mention any use cases, any interesting use cases these have enabled? I know Brian recently tweeted that Megaton is now being retrained using the new DGX model. So I'm sure that's going to break another benchmark, but anything historically that has been interesting?
Yeah, and so the way to think about the product lines, as from a research and data science perspective, of course, you can start out with the consumer grade. If it's a system that you were using just yourself, then a data science laptop or a data science workstation, using those Quadro cards, are very good systems. When you move up into something that you want to run stuff unattended, you want to have remote scheduling, you're kind of going beyond what would just be on your desktop work environment, that's when you move into the data center grade cards. The Quadro cards, are rated to run in servers and some of those versions, but it really comes down to what feature sets you're going to use, how big the memory is that you want, how performant you want those systems to be. And we now have the A100 series in all the clouds, so you could just rent it for a couple of hours, or obviously you could buy one of our DGX systems. So we want to make it really available for people, so they're not necessarily having to choose, well, do I buy a workstation? Do I rent it in the cloud? Do I buy a DGX? Everything is available, so it's there for you when you need it at the right price point.
Makes sense. So to break down the naming, there was the original DGX box. This, I think, is the second generation, and there was an A100 before this as well, if I'm not too wrong.
Yes. So we, on the DGX server side, we announced earlier in the year at GTC the DGX A100 server. So that started out with our 40 gig GPUs. And the exact same physical box, because you can't tell the difference from the outside. Just this week, we announced the 80 gig GPUs that we call the DGX A100 640 gig. And that's just the total amount of GPU memory. So the spring version was 320. This is doubled at 640. In the newest version, we, of course, doubled the system memory and doubled the drive space in it to keep up with the amount of GPU memory. But yeah, it's the same box. It's everything is the same inside except for the GPU tray and the amount of RAM in it. And the good news, and this is a core design philosophy that we have, when we built the box that we launched this spring, we knew 80 gig was coming. We knew HBM2 memory was coming, or sorry, HBM2E memory was coming, and so that was already designed into the system. And so we designed it so when this new technology came in, it's just a slide in replacement. So for our customers that already bought DGX systems, they'll be able to get an upgrade kit from us. So they can, same box, they don't need to take it out of the rack. They can just slide in the new parts. One of our professional installers comes out, does the swap, and all of a sudden they've got double the capacity. Obviously they've got to pay for that, but they don't need to rip and replace their system or throw it away.
I wish there was at least a sticker to tell my colleagues that, hey, I have the new one and you all don't.
We did debate things like that internally. How do you know you've got the new one? On the when you're dealing with large server cluster infrastructures, it's just like you see in my background. I love the virtual background effects. That's a rendered view of our Selene supercomputer behind us. You can't tell the difference. When we built that Selene system, the first systems were all 40 gig, and now over the last month and a half or so, we upgraded everything to 80, and that's what got us our great results on top 500. But yeah, they don't look any different from the outside, but the people that use them know they're different.
Makes sense to me. How do you I know we had this discussion offline as well. There's a lot of debate, I'm sure, that goes on internally. How do you spec out such a machine, which already is very ridiculous to someone like me? 640 gigs of memory, can't imagine using that. I really struggle with filling the 3090 already right now. But how do you spec out such a machine? I'm sure every single component is debated, so how do you come up with that?
Yeah, and so like I said, our design philosophy starts, with the GPU and how do we keep that, 100% utilized, and then we start looking at the other components to make it easy for customers to utilize all that GPU capacity that they have. So, we don't want anything to block IO. So we, very carefully design the internal PCI topology of the system. We need to make sure we can get enough data into the system. And with the new NVIDIA networking technology that came in through the Mellanox acquisition, we were able to upgrade our internal IO also to Gen 4. So not only did we increased to Gen 4 in this generation of DGX, we also doubled the number of cards in the system, or basically moved from a single GPU or two GPUs used to go to one network interface. Now it's a single GPU goes to a single network interface. So we doubled IO with Gen 4, then we doubled it again by adding the number of cards, because we wanted to be able to build out something like you see behind me that is a very large clustered system. So everything goes to that design center of, low latency, least number of internal hops, highest total performance, and then cost is really the last factor in it. We design a system, Jensen tells us to go build the best. And then, the team goes and does that, and that goes, not only from just, the internal parts, but it's the industrial design. You see the system obviously looks beautiful, but inside it's very serviceable. We spend a lot of time on that because we run a few thousand of these systems internally to NVIDIA just for our own researchers. And our team wants them to be easy to service, easy to use. So, we just, build it as the theoretical highest performance, lowest latency, best overall throughput system, so that we can show the world what's possible. And then customers can always choose to buy our DGX system, so they can choose to buy one of our, great OEM system products out there. The DGX system comes in one configuration. We have a couple of small options on it, but it's basically one configuration. Now, as a customer, you can say, okay, I want that. I want the best. Or you can also say, well, for my specific use case, maybe I need a lot less disk, or maybe I don't need as much memory, or maybe I have a different networking topology. And that's where our partners come in, because they provide all of that same great flexibility. We're never going to build that as NVIDIA. We just want to build one system, as the reference standard, and then let our partners build all the different, permutations that a customer may want. And it's great for us because we can help our partners, so they don't have to design everything from scratch. We're very transparent. Everything I do in DGX, I share with all of our partners, so they can build really great systems too.
Right. And lingering onto the network interface part, I just going on a tangent here. I wasted a few minutes of Charlie trying to switch to my cellular because my fiber internet wasn't cutting it. And when you have such a, if I may, ridiculous amount of performing system, the network may become a bottleneck, surprisingly. So you really want to have individual IO ports for different cards.
Yeah, and that was something, we debated that internally too, because when we went to PCI Gen 4, we said, oh, well, performance doubled. Do we still keep a 2-to-1 ratio? And our head of GPU architecture, our heads of engineering, we all got together to talk about it. We said, you know what, for the small incremental cost to do that, let's just put the maximum amount in that you could theoretically do. And it's really paid off because, as you see in our top 500 results, without changing anything else in the system except putting in the 80 gig boards, we got, a 25% energy efficient boost, in our ratings. We went from number 7 to number 5 on the list. we could have only done that in the short amount of time that it took us to do it if we didn't need to change the network. Because recabling, a few hundred systems in a data center in the middle of COVID is not quick. But, putting in that networking technology, and that's, a message that I talk to all of our customers about, overbuild your network now. It's going to cost you a little bit more money now, but it saves you so much headache in the future. You don't want a year and a half from now to have to recable your data center. That's one of the biggest pains. We've been through it a lot internally because we obviously do a lot of lab infrastructure. But as a longtime data center guy myself, it's like, racking and stacking systems is easily. Cabling a data center is really difficult to do it right. And it's expensive. So, for the amount of money you would have to do a partial recable, you could have spent the money and gotten a much better network to start with.
Even in general, you mentioned having a little or a good amount of headroom is helpful. That's where that comes into. Whenever you need upgrade, you can go in without a headache.
Yeah, and that's part of our design philosophy too. We build the systems. You look at a DGX A100 server system. It's got fully redundant N plus N power. It's got 6 3,000 watt power supplies, but our rated usage of the system is somewhere between 5,000 and 6,000 watts. So you've got a lot of overhead if you need it, but we also build it for redundancy too, because it's not in a data center you worry, does a power supply fail? Okay, that's not going to take out the system, but what's really important to large scale clusters like what you see behind me. What happens if you lose a data center phase? So you lose half of your data center power. Well, you don't want to crash thousands of systems. So that's why we build in N plus N redundancy to the system.
And I think these are points that no one really realizes, even individual enthusiasts. When we build a PC, we realize, oh no, my budget isn't going to cut it because now I need a UPS as well whenever the power goes out, because I don't want to blow the complete house's power supply.
Yeah, no, I know that feeling. I'm in California here, where our power situation is less than stable. So and yes, in my house, and I'm working on some other project that's still under construction. I've got backup generators, I've got UPSs. But that's just the data center guy in me. It's like, well, I grew up with that technology, so of course I'm going to have a UPS at home, and of course I'm going to have a generator.
So just going over the specs here, as if this was a PC part picker list, which of course it isn't. But there's a 64 core CPU in there, half a terabyte of memory, and of course the GPUs in there. And still, it consumes a very small amount of power. So could you speak to that, and how did you make that happen?
Yeah, so the the DGX station product has a slightly different soul than the server product. The server product is absolute fastest performance, no compromise. The station product has a high performance goal, but it has 2 other critical requirements. One, it has to plug into a wall socket anywhere in the world. So, that varies from, power in Japan that's 100 volts, power in the US that's should be 120, though a lot of guys don't actually deliver that. When I plug a voltmeter into my wall, I'm like, 107. I'm like, that's a little low. But so, our design goal on the station system is high performance, but the top goal is plugs into wall power anywhere in the world, and it's quiet. And when we're talking quiet, we're talking, in the 30 to 40 decibel range. So, a very quiet system. And then that system, we count watt by watt, every component in the system. How can I remove things that eat up power so I can put more power to the GPU? Because any available power in the system, I want to give to the GPUs. So, how do I cut down not needing extra PCI switches? Because they're functional, but they take up power. So we look at that system, and then we dial in the GPU power curve, because we're using a full 4-way HGX board. So that's the exact same board that's in all the new supercomputers that have been announced. But the server version, well, I mean, it's not a different version. It's, the server power level on those boards are 400 watts of GPU. Obviously, I can't run 400 watts of GPU times 4 and fit with under 1,500 watts. Math just doesn't work there. So, we dial in the GPU power curve so that GPUs get as much power as we can, and we dynamically allocate some of that inside the system too. So, as different things aren't taking up as much power, you can give a little more power to the GPU. As other things may be taking up more power, we can, balance it down a little bit. It's not a huge swing in the system, but that's one of the highlight differences between a server product and the station product is we always keep under 1500 watts, where the server can nominally run at 100% in the 5000 watt range, but you may have some workloads that push it up to 6000. Well, obviously that wouldn't work on something you plug into the wall to have a 20% bump in energy usage, because you'd probably trip a circuit. So our designers are really careful on that. We run a ton of extensive tests on it in the labs. The power supply that's in it, by the way, is actually a 2000 watt power supply. So the power supply has tons of extra power, but we put caps and limits on it to make sure that we're not going to blow up wall power. And then the other thing that we did that was really interesting in the original DGX station product was liquid cooled. Had a fan radiator set up. It's still very quiet, but as any liquid cooled system, over the years might require some maintenance. There was never any leaks in it. It was all very, instant connect type of thing, no drip setup. We did a ton
And
of
sometimes you can hear the pump whine, as people call it, as well.
That was, it's a really interesting point, because we went through a lot of different pumps, because if you look at a pump spec sheet, they'll just list the amount of noise that it produces just in decibels or sones or anything, but it's that pitch of the pump that really matters. So we went through in the original station products, it was liquid cooled, moving liquid, that we actually went through a number of different pump suppliers to get not only the noise level right, but the frequency of it right, because you have that even if something's not that loud, but you can hear it because it's different. The new setup that we went to, because we wanted to push the limits of engineering, but also if you look at that board, the GPU board that's in the system, it's a server grade 4 GPU setup, and we needed a way to keep all the all the GPUs at a constant temperature, all in a cooling loop. So we actually went to a refrigerant design. So the guys did a tremendous job there. A lot of engineering work went into it. If you see the video that we have on the station, they do an exploded X-ray view that you can actually see all the refrigerant pump setup. And the interesting thing is they were able to do all that refrigerant work and still keep the refrigerant non-toxic and non-flammable. And even the little ice maker that sits on my kitchen counter has a warning on it that said, warning flammable refrigerant. I'm like, this thing's making ice and it's flammable. But the DGX station is non-flammable and non-toxic, and it's completely maintenance-free, which is something, we didn't have a lot of customers that needed to top up their original liquid-cooled stations, but having something that for the life of the product is maintenance-free, was really a big asset this time.
So is this actively or passively cooled? You mentioned it's there's a refrigerant in it.
Yeah, so it's a refrigerant-based system. There's refrigerant pump in it and a radiator setup. And all of that works together. So it's in the interesting thing of the way the refrigerant works versus typical liquid cooling. In a liquid cooled setup, you'd want everything in parallel, because you don't want the warm liquid from one component then warming up the next component. In refrigerant, because, and I don't understand all the chemistry, I'm not going to pretend that I do, but with the refrigerant set up in a serial loop, we can still keep everything at a constant temperature. So it simplifies the routing a little bit. The cold plate on this is extremely complex, as you can imagine. And that's when you think about design engineering, the engineers that had to build a large cold plate that would fit on top of 4 GPUs exactly right, and deal with shock and vibe, because we put these systems through massive amounts of drop tests and shock and vibe stuff, to have a huge cold plate survive all of that with no problems, is a big engineering feat.
Did you debate having a custom loop with some cool colored liquid flowing in it? Was that ever brought up in any meeting?
No, we didn't debate. Refrigerant isn't actually colored. I've seen how they fill the systems, and it's refrigerant depending on the temperature is a gas or a liquid. So can't really change the color of that too much. We did have debates whether we have a clear side panel. If you've seen some of our display units, those do have clear side panels on them. But from a rigidity and shipping and everything, we don't ship with an open clear side panel because it just doesn't meet the mechanical rigidity that you want in a system like this. The system weighs about 100 pounds, but we have to ship it all over the world. And while we're very careful in design and we're very careful in the factory, you never know how international freight is going to go. So we build it like a tank so that when we ship it, it's just as perfect when it shows up at the customer site.
And all of these are ridiculous points that never come up. But even when I was buying my PC and having it shipped up, I was literally debating, should I get an insurance? Should I not get one? Because they are all of these components that can move, especially the GPU. And these things just go unnoticed. Probably no one even thinks about them before buying one.
Yeah, and that's partially what we try to do with the DGX products. It's also peace of mind. One of the big compliments that I get from customers, and it was we started getting these in the first year as we started doing DGXs. Their feedback to us was, it's great, it just works. They didn't have to do anything to it. They plugged it in. Maybe they had a software update to do, but then it just worked. And that's really what we strive to do. We don't want people to have to spend a lot of time doing integration, everything. So that's why all of our systems ship with complete DGX OS, all the latest NGC containers you can access instantly. So it's a great just customer value. If you're doing this for your primary job, you don't want to buy an expensive piece of equipment and then spend a month trying to get it all the kinks worked out of it. You want to buy something, plug it in, turn it on, and start doing your work.
Absolutely. The reason to share with the audience that I was geeking out over all of these specs is historically the workstation cards have had a lower power usage, and that's just because they're more catered to that. And that has always led to bleeding that into the consumer cars. Like we saw a huge power efficiency increase in the 3000 series. So that makes it more exciting that, hey, even if I'm going to get a 4090, 5090, it'll probably have even better performance or more memory. Who knows?
Yeah, and the big game changer on the memory that we use in the data center products is that HBM2 memory, and now HBM2E, that sits directly on top of the GPU die. So it's you get a lot more bandwidth between those things. It's a more expensive type of memory. It's more difficult to manufacture because you have to build a chip and then you have to put this memory substrate on top of it, package it all together, make sure everything works. So it's much easier just to create a GPU and then solder in a bunch of DDR memory around it, but you get so much better performance and capacity out of that HBM memory because the HBM memory, while it's more difficult to work with, is a lot more power efficient and has larger capacity. If we tried to put 80 gigs of, DDR6 or whatever, around the GPU, it would be, very difficult to power, and, the latency would be bad. Having the memory chip physically sitting, micrometers away from the actual, GPU chip, your latency for your pins connecting those things together, it's like, near zero. So, that's, one of the other advantages of the data center products. When you move up into that range, it's much easier for us to add a lot more memory capacity versus trying to put memory chips around a GPU.
And again, these terms are relative, that this is relatively harder to create in 3-4 years. Again, as I'm sure different iterations go through, these would become easier, and again it'll bleed into consumer products as well. That's my hope, at least.
Yeah, and that's what I'll have to leave to the chip design experts of, how long does it take, something like an HBM technology to make it into consumer grade parts? Does it ever get there, or if you look at the two paths, does traditional memory also get less expensive at the same time, and where that crossover path is. Like I said, I'll leave that to our architecture experts of where that is. But one of the things that we that all of our customers benefit from is that trickle down design. All the software that we write and test and performance tune all starts out on a DGX. And so even if you haven't bought a DGX, you've gotten all of the NVIDIA tunings, whether you're running that on a Tesla OEM system, whether you're running that on a Quadro system, or even if you're running that on your consumer parts. All that software optimization for the latest GPUs, all came, from a design center that was run on a DGX, probably on a system in a node that's, in the background behind me right now. And so that helps everyone.
That makes sense. So there was another interesting point that I really wanted to discuss. It's called MIG, and that essentially allows you to create, if I remember correctly, 28 independent instances on the GPU. So if you could speak about that.
Yeah, on the DGX station, you can have up to 28. So this was something that it was developed based on a lot of customer feedback over the years. Even, when I had DGX systems, I had customers telling me, hey, Charlie, these systems are really great. The NVIDIA GPUs are getting so much, more powerful, and the memory is getting so much bigger. The usual ask was, well, how do I share that GPU? Sometimes people would ask, well, how do I virtualize that GPU? And we took all that to heart, and we did actually support virtualization in the DGX2 platform. But anytime you add a hypervisor to a high performance thing, you get a lot of overhead. And we were able to squeeze that overhead down some, but it still didn't, you were still giving up too much. So in the A100, we were able to design in the chip this functionality that we call multi-instance GPU, that everyone refers to as MIG. And that allows the chip itself, the chip has logic inside of it that you can set this mode, and the chip divides itself into fixed partitions of number of cores and amount of GPU memory. And so on a DGX server, you can have up to 56 of those, because it's 7 MIGs per GPU, and we have 8 in that. But in the in the DGX station, because it's got 4 GPUs, you can have the 28 MIG slices on that, and each MIG slice is about the performance of a V100. So when you think about that, it's like having 26 V100s in your workstation. Now, the physics of that is impossible, because if I put 26 GPUs in a workstation, I'd have to connect it to the power line outside of my house. But but now we're able to, give users that, that functionality. And that's why, we tend to talk about the DGX station as, a work group appliance. Sure, we're going to have researchers around the world that are lucky enough to have their own system. But the real value of it, especially, in the data science realm, where, you're trying to collaborate and have everyone use their best ideas together. Well, if you're all working on the same DGX station, and you can have up to 26 experiments running at the same time, that could serve, a couple of users all running multiple experiments, or you could have, a range of users and give them all, 2 MIG instances. And when you look at what, a small MIG instance gives you, that's the equivalent of a few cloud servers just on their own. So now customers, can very cost effectively share one of the DGX stations. And that's a huge benefit, because it's not just something that you have to buy for yourself, though I'm sure there's researchers and data scientists around the world that are drooling, asking their boss, all I want for the holidays this year is a DGX station. But it's something that, you can say, oh, we deploy these even internally, to our remote offices, where, we may have a handful of people, in that remote office. Maybe there's 2 DGX stations. Of course, they have the ability to come back to the main data center to do their work as well. But, often if you're collaborating with your research groups, your colleagues, you just want to do quick stuff. You want to tear things up, tear down experiments, add new stuff, kill jobs in the middle of things. And by having that local control really gives you that, that power to do that. And MIG just gives you so much more flexibility. The other thing that we added in this generation of DGX station is it's extremely remote controllable. So it's got full remote management on it. So, in the time of COVID, if you want to ship one to, one of your colleagues' houses and then everyone logs into that remotely, or, you ship it to the office and have, anyone who's still left in your office or that comes in occasionally, just literally plug in the power cord and plug in Ethernet to it, and you can do all of your setup remotely on it. So, MIG gives you incredible flexibility, and then, making it extremely easy to use anywhere means that, you can power your entire work group from the office or from one person's home. Doesn't really matter.
So if you've shaken your hands with your colleague, telling them that, hey, I'll only use X amount of memory, and they end up breaking that deal, you would not have a nicer lunch. And this does happen quite often. But as you mentioned, there's no overhead to this, negligible overhead, because this is all hardware controlled.
Yeah, and the great thing about MIG is everyone that gets a MIG partition, you have defined memory and defined cores, so you can't clobber your colleague. So, and that was one of the big requests, and it's an honest request, because we had in previous generations on a Volta series, a Turing series, or a Pascal series, you could always share at the CUDA level. But we always called that, social sharing or, Slack sharing, because, you had to say, you had to message your colleague, like, I'm going to use GPU 1 right now. Don't anyone use that.
Yes.
But now with MIG, you assign out the GPU resources to people, and you can use that resource that you have, because to your program, it just looks like a GPU. It's a CUDA device. So you access it, you can pound that at 100%, and you're not going to hurt any of your colleagues. So that really frees people up, on this type of work group setup, is that they don't have to worry about what their colleagues are doing. At the beginning of the day, or, however you want to set it up, you set up the partitions you want, you hand them to the people that get them, and then they could use it 100%, they could use it 0%, and nobody knows the difference. The other great thing that you can do is it's dynamically reconfigurable. So anytime the GPU is at rest, you can change it from MIG mode, non-MIG mode, change your partition slices. And what's really great about that is you could say, okay, during the normal work hours, and with COVID times, normal work hours are, a little different.
Yes.
But you could say, as the team is doing their normal work day, everyone gets their partition. And then in the evening, when they're all sleeping or gaming, that you can turn all the MIG mode off and turn it into, a 4 GPU NVLink monster and run batch jobs on it all night, and then come in the morning and see the results. So you've got a lot of flexibility, and you don't need to add virtualization software to make use of that. And truly, there is no overhead, because it's actually, when you turn this software switch on, the software switch pokes a register in the silicon, and that just says you have a full GPU or you have MIG slice of the GPU. So there's no performance penalty to it. It's just all about capacity size and number of cores that you get.
So you don't need to go into BIOS, have your PC reboot, and you just enter a command in the command line. And when you go NVIDIA SMI, you see essentially GPU 0 to GPU 28 or 56, depending on the...
That's exactly it. Yeah, I mean, we wanted to design the feature so that people could change when they needed. And the only reason that I don't tell you that it's real time, and I say dynamic, is because you have to make sure the GPU is idle before you make a switch. Because if you change the the registers inside of the GPU while someone's running a job, of course their job is probably going to fail, because you change the memory space on them. But we have a lot of tools around this to help people. We've integrated this technology with Kubernetes and other schedulers, so the schedulers are aware of it too, to the point that if you have a cluster of systems and you ask the scheduler for a MIG slice that doesn't exist, it can look at your cluster and say, oh, well, the particular slice that this user wants doesn't exist, but I've got GPUs that are idle, so I just switch the mode and then give them the resource. And you can even use like a Kubernetes kind of scheduler or a Slurm scheduler on a DGX station that's not just for really large clusters.
Just I like to share my stupid adventures on the podcast a lot, just sharing why this sounds exciting to me. In my very ambitious project, I wanted to run a VM, actually 2 different VMs, where I could just edit a video on Windows using one particular GPU, and have something train on Ubuntu using the other GPUs. Of course, that didn't go well because I didn't know there's something known as overhead. I learned that the hard way, but that's why this sounds very exciting to me.
Yeah, no, the overhead thing is something, in the typical data center world, of course everyone uses VMware, and and that, and they've done a great job over the years to bring down the overhead, but the value of virtualization outweighed the overhead that you got with it, because typical servers were 10 to 15% utilized 5-6 years ago. So putting a virtualization technology that could get you 70% utilization, even if you had 10% overhead, didn't matter to you. But when you're talking about a GPU resource, that's such a high performance resource that you tend to notice overhead. But that's why we work with all of our virtualization partners to figure out how we can minimize that as much as possible. But it's a lot of hard work and a lot of engineering. But we made an announcement earlier in the year that we're doing a lot of work with VMware to optimize that for data science and deep learning as well. So we continue to work on the software side, not just the hardware side.
Sounds very exciting. So where can people check out the A100 systems? Is it already up on the cloud, or is there a date when it goes live?
Yeah. So in the continuum of A100 systems, the DGXs are available for order now. If you wanted to try an A100, all of our major cloud providers have made announcements on that. I think most of those cloud instances that you can get access today are the 40 gig instances, because obviously we just announced 80 gig on yesterday, Monday this week. And so, those will all get into the cloud. But if you wanted to try A100, it's available in the cloud. You can, I know I've seen announcements from Amazon and Microsoft and Google, and I even saw, Amazon had it on their public list right now. So you could literally, with the credit card, get access to an A100 right now, anywhere in the cloud, and then see how that works for you and see how much you need. And if you want to stay in the cloud, that's great. We love our cloud providers. If you want to, run it in your own data center, you can buy some DGXs to do that. If you want to run it in your office, the station's good for that. So we really try to make the technology available everywhere. I'm the DGX guy. I'd like you to buy DGXs, but at the same time, if you're using it in the cloud, I'm super happy with that, because you're getting the advantage of the whole NVIDIA platform.
Awesome. I particularly don't think I'll ever need DGX in any time soon. I'm struggling to keep this under full load, but for anyone in the audience, please feel free to check it out. I'll try to have the particular links in the show notes. Charlie, before we end the call, would you like to mention any platforms where someone from the audience can connect with you?
So, I think the best thing, check out the videos that we released on NVIDIA.com. Our new YouTube video that shows you what the station looks like has been super popular. It just launched yesterday. We're over 100,000 views today, which is, it's something always, that brings a smile to my face, because as, a data center, person, enterprise computing person, we don't tend to get a lot of consumer crossover, but being able to see those great assets that are online. I'm the only Charlie Boyle at NVIDIA, so you can find me on LinkedIn. And if you want to connect that way, that's great too. And we've got a fabulous army of experts around the world. So no matter where you are in the world, if you want to learn more about DGX, you can always start online. And if you need to find your local NVIDIA resource or NVIDIA partner, there's great resources on NVIDIA.com to help make that connection for you.
Awesome. Thanks again, Charlie, for your time and for shedding light on all of the internal engineering and all of the fascinating stuff, at least to me and hopefully to others, that goes on behind all of these designs that come out of NVIDIA's oven. Although I don't know if this one would fit into one.
Yeah, you have to have a different shape often, but it's all good. And we really appreciate the time too, and the enthusiasm. A lot of people worked really hard to make these things happen. So I'm only the spokesperson for the people that do all the hard work. And I'm really proud of the whole team for pulling this off and doing so without missing schedule in the middle of COVID. I think, we all have to work differently. And, I appreciate everyone in the audience watching this, because because, we'd love to see you at a show like Supercomputing where you could touch a DGX station, where we can have dinner with you and, and explain all this great work. So, I really appreciate this opportunity to be on the podcast so people can see these things virtually, until we can get back to a point where we can see everyone in person.
Thank you so much. It was really an honor to have you. Thanks for your time.
Yeah. Thanks for the time.
Thank you so much for listening to this episode. If you enjoyed the show, please be sure to give it a review or feel free to shoot me a message. You can find all of the social media links in the description. If you like the show, please subscribe and tune in each week to Chai Time Data Science.